So good morning. So today we'll be in the last topic. Okay. Uh, so we are going to see about an hooks and scoops. Okay. So first of all, we are in need to know what is the soft scoop gripper. Okay. So it is an under actuated tendon driver gripper. With this, we'll have two flexible fingers, which is composed of six soft rigid modules, each and a scoop. Okay. So these modules which can be assembled with different stiffness values at flexible joint level, and they can be obtained through changing 3D printed parameters during manufacturing. Okay. So whereas the hooks and scoops in the path of dinner, they are to be the simplest type of end effectors, which can be classes of grippers. Okay. So when we are saying about a scoop or a ladle, which is commonly used to scoop up molten metal and transfer it to the mold. Whereas the hook, it may be all that is needed to lift a part, especially if precise positioning is not required over on it. Okay. Whereas in the case of hooks in the Patana, they are used to load and unload parts hanging from the overhead conveyor. The parts to be handled by a hook, which must have some sort of handle, eye bolt or ring to enable the hook to hold it. Whereas in the case of scoops, they are used for handling the materials in liquid or power from the limitations of the scoop it is. So it is difficult to control the amount of material being handled by the scoop. In addition, the spilling of the material during handling is another problem over on it. Okay. So these are about the hooks and scoops. Whereas in the case of an expandable bladder type gripper. Okay. When the case of an expandable bladder type gripper, okay, so it is a bladder hand, so it is a specialized robotic end effector which can be used to grasp, pick up, and move rod-shaped or cylindrical objects. Okay, so the main element of the gripper when the path of Dina, it will have an inflatable donut shape or a cylindrical sleeve, which resembles the commonly used as a blood pressure measuring apparatus. Okay, we are in need to know how it is works. So actually, the sleeve is positioned. Okay, so it surrounds the object to be gripped, and then the sleeve is inflated until it is tight enough to accomplish the desired task. Okay, and the pressure exerted by the sleeve, which can be measured and regulated using a force sensors over on it. Whereas the bladder grippers, uh, they are useful in handling fragile objects. However, they could not uh, do operate fast, and they can function only with the object within a narrow range of physical sizes. Whereas in the case of bladder grippers, they will have a related supply. There is a inflatable seal, the type of rubber seal which inflates over on it. Okay, and when you are saying about bladder grippers, so actually we'll have a different type. So we'll have a parallel motion, three jaw, bellows, O-ring, needle. Okay, everything we have over on it. Okay, and when you are saying about apart from that, we'll have active and passive grippers. So in contrast to active grippers, that is which requires the continuous pressurization, so that uh, the presented passive gripper which requires only for the release process. So however, it is due to its working principle. So actually, the gripper is restricted to only for the flat objects or objects with at least one surface. Okay. Uh, may anyone know who is the father of robot? So actually, Joseph F. Engelberger, an American physicist, engineer, and businessman. He was the birth of one who is the father of the robotics. Okay, and do you know who is the famous robotist? Actually, Joseph Engelberg. Okay, so he is the famous robotics and first real robot with a name and ceremony. So that is to be the a digitally operated and programmable robot was invented by George Deville in 1954, and it was ultimately called as a Unimate. Okay, and these are all the information which related to the robotics. Okay, so this is about the expandable bladder type grippers. The next one we are need to know what are the factors which is required for the selection of a gripper. what are the factors which is required for the selection of a gripper. Okay. Uh, so first, when selecting a gripper, so we should consider for the any application should include appropriate finger length, grip force, stroke, actuation time, and accuracy. Okay, and orientations and dimensions. There is a which affects the gripper selection. So, and the next thing we have to consider the size, and similarly we have to check with the variations, everything and all. So apart from that, some of the factors which have been included here, the coefficient of friction between the gripper and the object, which may be also an important factor. Okay, not only the mass of the object, but also we have to consider the accelerations imposed on it by the robot. Okay, so this can often be increased by using one of the special rubber-based materials which have been developed. And apart from that, the use of these materials which can create maintenance issues, however, they will be having the finite life. And one way of reducing the gripping force was the பார்த்தோம் அப்படின்னா to use fingers designed for the form for the component. And similarly, it can able to reduce the flexibility of the gripper, but dramatically பார்த்தோம் அப்படின்னா it increase the weight carrying capacity. Okay. So weight cases பார்த்தோம் அப்படின்னா industrial robots which have a fixed lifting capability and the combined weight of the gripper and the grip component may be important. So even where this weight in the capability of robot, it may cause an unacceptable increase in the cycle time of the operation. So this is between the robot plane and the center of mass, which may be the important one, it should be kept here. And the second thing, the factors which is needed to take over a supply of services. There is a within a robot end effector, it can lose cable or houses, something to be avoided, and it can increase size of the tool, and it is therefore preferable to route all services or signal connections to the robotic arm and then internally to the tool. The next factor we have to consider about its environmental capabilities. So the end effector has to be work in coastal environment. So high temperatures, just the presence of chemicals the require special materials are designed to be used. The next thing to be the sensor capabilities. So some degree of sensory feedback from the gripper is necessary. So this may be a measurement of insertion or gripping force or may simply be proximity sensor. Okay. Some standard grippers are provided with feedback to show the separation of the jaws, but most grippers have no feedback over it. So other factors it include the speed of the gripper jaws, range of sizes of components, and the amount of maintenance required is also important to work here. But also they use either springs to apply the gripping force or not. Tool as an end effector. So tool it is equipped in the robot for carrying out the several operations. So this tool will act as an end effector when it is attached directly to the robot cells. In some applications on data, there will be a need for multiple tasks, which will change the tool all the time from the robot wrist will be high difficult. So as a result, the gripper is used in the process to grasp and manipulate the tool. Okay, it certainly helps the robot to handle several tools in an operation. Thus, it makes the multi-tooling function possible. Moreover, the time taken, which is too. In robot applications, uses 3 tools as an end effectors over on it: part welding tool, spray painting nozzle, arc welding tab. And we'll have a rotating spindles for operations, drilling, routing, wire brushing, and grinding. And apart from that, we'll have a liquid cement applications for assembly, heating tests, and auto jetting tools. And finally, we'll have a unilateral or multilateral. Unilateral name uni, which indicates only one point or surface touching the object. But in the case of multilateral, we'll have more than 2 points of surface the components to be handled. Okay. We'll have vacuum thread gripper and electromagnetic gripper. So I've shown an example problem, which is the gripper is simply pivot type. The gripper force is calculated in the as the 60 lb. The gripper is to be activated. So the responding lever. So the analysis will be having a FGLG minus FALA. So you have to calculate the what is the force of acceleration. So we're getting of a 240 lb over on it. Okay. So this is the way. These are all the inputs which is behind in the thing over there. Okay. So by that the second unit gets over. Thank you.